we are continuing Chapter 8, Section 1, dealing with multiplying and dividing rational expressions. Right now, in problem number 5, we are going to break these down into their prime factors. So right now, I'm listing x to the 4th as a whole bunch of x's, actually technically 4. X to the 3rd, I'm going to write down as x times x times x. These little dots are just multiplication. We have a minus 2, so I'm going to put like a negative 1 times 2 times an x and times an x. In the denominator, once again, I'm going to list everything into its prime factors. Got a negative 1 times an x times an x times an x. So we got everything broken down. So right now, what we're going to do in this rational expression right here is we got to find what's called the greatest common factor of this variable, this monomial, and this monomial. So what's the greatest common factor that they all have in common? Good question. 2 what? X is being multiplied to each other. So, what is an x times an x? That's an x squared. Now, we've just factored out the greatest common factor of this expression right here in the numerator. Now, I factored out an x squared. What does that leave me with right here? That leaves me with another x squared. Very good. Right here, what does it leave me with when I factor out this x squared? It leaves me with just 1x. And what does it leave me with here when I factor out this x squared? It leaves me with a negative 1 times a 2, so it leaves me with a negative 2. So this is how you would factor out the greatest common factor out of the numerator. Now that you've done that, you're going to look at the denominator. So switching colors. Let's look at the denominator. What's the greatest common factor between an x to the 4th and an x cubed? What's the greatest number of x's being multiplied to each other that we can factor out of both of them? 3 there, and there are 3 right here. So I can actually factor out an x cubed out of the denominator. Now if I factor out an x cubed right there, because that's the greatest common factor to both of them, what do I have left with this guy? An x. What do I have left with this guy? That's it. Now how in the world do you check to see if you did it correctly? I would use the distributive property. What is x squared times x squared? What is x squared times an x? X cubed. And what is x squared times a negative 2? Negative 2x squared. And you can do the same thing to the bottom. Now we are almost done. If I have an x squared in the numerator, and I've got an x cubed in the denominator, these cancel all but what? All but 1x. Now if you didn't know how I did that, basically you got an x times an x right there. You got an x times an x times an x right here. And so this cancels this guy out. This cancels this guy out to a 1, and we're just left with 1. Now, there are students who know how to factor, and there are students who do not. This is a trinomial that can easily be factored if you know the rules for factoring a trinomial. So even though you can't see it, I'm going to put the number 1 right here. You're looking for 2 numbers. When multiplied together, equal a negative 2. And 2 numbers, when added together, equal a positive 1. This is what you can do when you're trying to factor these. So what 2 numbers multiply together to equal a negative 2 and add together to equal a positive 1? Negative 1 and a positive 2. Negative 1 and a positive 2. So you could write x minus 1 and x plus 2. Now we're not going to review the FOIL method in this video, but if you've ever watched any of these videos, you've probably seen the FOIL method a lot. But if you multiply these together using the FOIL method, you can get back to this trinomial right here. Now, everything is factored. This times this gets me back to this trinomial, and we've got an x times an x minus 1. Does anybody see anything we could possibly cancel out in this expression? That's right. So these cancel out. And what's the only number left now in the numerator? An x plus 2. And what's the only number left in the denominator? And this right here is your final answer. Now, sometimes they rewrite things, okay? So in a multiple choice, this is what you get, but you don't see it, because they might say x goes into x how many times? 1. Plus, x goes into 2, well, it doesn't. This is another way you could write the answer. You could say it's 1 plus 2 over x. But I think this right here would be the answer I would look for from you. Okay. A lot of times on an SAT test, like an A, B, C, D, E answer choice, I've come up with answers that look like this, and I have to search for the other alternate answer. Okay. Moving on to problem number 6. Write that down in your journal exactly as it appears, and we'll show you how to do it. All right, let's do number 6. Right now, what I'd like you to do, simply break this down into its prime factors. Call it a negative 1 times 2 times a u and a u and another u and over. There you go. Right here, a negative 2u cubed, y is equal to this. And we're going to break down the 25. What are the prime factors of the 25? Good. 5 times 5 times an x, another x, and another x. And we'll try to break that one down. Okay. Go ahead. Right there. Break down the 15. Come on. Put down the 5. 3. Okay. And a 5. You got an x. You know what? I really don't feel like it. I'm just going to leave it as the end of the bit because there's no other reasons. Let's just leave it like that. Don't feel like writing more. Emily, break that. All right. All right, there we go. Now what we're going to do is we're going to cancel things out with the numbers first. Jacob, just scan all these numbers. Is there anything in the numerator that you could possibly cancel out in the denominator? Using some lines, you just focus on numbers right now.
Numbers, no.
All right, I see a 5.
Oh, yeah, 5.
5. Ooh. 2 here. There you go. All right, so what do we left with numbers? What do we have left? We got a and a. What does that get? I don't like it. Let's put all our u's and x's and y's together. How many u's do we have? We got u cubed, got a y, but you know what? Let's do alphabetical. Got an x cubed and a y. What numbers do we have left in the denominator? 3 and 7. What's that? 20. See here. Ooh. I got a u squared, right? Got an x. We're going to go the extra mile. Just put a 1 right there. I don't know, it's really bad. Extra mile. All right. How many y's do we have? We got a y squared. And finally, how many z's am I going to put there? Z to the power of 5. Very good. At this point, everybody, what we need to do is what's called the quotient property. The quotient property. I forgot what the quotient property is. That's okay. I'm going to write it once again. So we're allowed to do what with the exponents? We're allowed to simply subtract them. By the way, negative 5/21 cannot be reduced. That's it. That's as much as you're going to get. We've got a 3 minus a 2. What does that leave with? That's right. I heard you, Leon. 1 right there. But since we're cool, we're not going to put the 1 there because we know it's automatically assumed that's u to the first. Right, theta to the first. All right, got a 3 here and a 1 here. What are we going to do with those? That's right, I heard you, Angela, who's not invisible. X squared. All right. Uh-oh, this is where it gets tricky. If I do 1 minus 2, that gets me y to the negative 1, but that means it's actually 1 over y, so make sure you put the y down there. This guy cancels everything but that 1 right there. And what do we still have left in the denominator to finish things off? C power. This, my friends, is your final answer. I know it looks a little weird, but it'll be okay. Now we have one more problem to do on this video. We're not doing number 8 because it's way too easy. We're going over the problem number 9. So put problem number 9 in your journal. We're going to do it in under 3 minutes. All right. Where students mess up on this one is they forget that these are all to the power of 1. We need to do what's called a power of power. Which means this is not just 2 to the first, this is 2 cubed. What is 2 cubed? 8. Just put an 8. Then put in x cubed, y cubed, over power of a power. What do we do with the 3 to the 2? Multiplies with w to the 6th. Now, everybody, we're going to change the division sign to a multiplication sign. And then we're going to take the w to the 5th and we're going to put it up in the numerator. And the 24x squared, we're going to put it into the denominator. Because we've just changed this to what's known as its reciprocal. Back in the 6th grade, you learned something. You learned that when you divide fractions, you actually multiply the first fraction by the reciprocal of the second. Back in the day, you probably heard a teacher say, keep it, change it, flip it. Right? Keep it, change it, flip it. Which basically means you multiply by the reciprocal. So right now, let's see what we have here. Does 8 right here go into a 24? 3 times. W to the 5th. All of those get canceled out. And how many do we have left now? 1. Just 1. Ooh. X squares. All of those die. And we're left with just an x. I don't see any ones. Right now, let's see what lived. What lived in the numerator right now? What's the only thing that you see that lived? I see an x, right? What else? Y cubed. Very good. What lived in the denominator? A w and a 3. Very final answer. X, y cubed over 3w is your final result for this particular problem. So when you guys work on dividing fractions, remember, you take this fraction and you multiply it by the reciprocal of the next one, and then simplify it.